Assalamu alaikum warahmatullahi wabarakatuh. Karibuni tena kwa channel yetu Mind Mastery Tutor, na leo kama kawaida tutaenda kufanya chemistry. Na for those teachers who are watching, please bana, kama unatoka shule sijui huko wahitaji huko kwa bara sijui Laikipia, Letepia, sijui shule gani hizo, please send me papers man. I don't know what's the reason of you being stingy with papers when those papers money wauza. I don't have a problem, just text me through this WhatsApp. And for students who have such papers, especially you are in Alliance School, you can send me the paper through this number. I'll try my level best to solve that paper. If you don't know how to send a paper, but make sure you send it to me in PDF form, send it to me in image. Okay, so if you have such paper that you think is better for it to be revised, then send it to me through this number. If you're a teacher as well, send it to me through this number. I don't know for Alliance, lakini uko na stingy na paper na pia taka kuuza, I can buy, there's no problem, but usinigonge my friend. But let's start with this question. Chemistry is a very easy topic. Hii ni section A, the section B as well. Sijawahi ona hizi nikifanya KCSE mambo section A, section B, but all in all, let's start answering this question. Question 1. A grade 10 learner in a Kenyan school is revising branches of chemistry during a science club discussion. Name one branch of chemistry that deals with carbon compounds. That branch of chemistry, we call it organic chemistry. Okay, we call it organic chemistry. But let me just write it here. Organic chemistry. So organic chemistry deals with carbon compounds. Those that doesn't deal with, there's also a branch of chemistry that deals with non-carbon compounds, and that is called it's called inorganic chemistry. It deals with non-carbon compounds, especially alkaline metals, alkaline earth metals, which are not carbon compounds. Okay. There's also physical chemistry, there's biochemistry, and etc. Question 2. During a community health awareness campaign, a chemist explains safe drug use. What's meant by the term dosage? Now, dosage is the prescribed amount. Okay, is the prescribed amount of drug to be taken. It's usually prescribed by a medical profession. Okay, so let's say it's the prescribed amount of drug to be taken over a given period of time. But mostly it's prescribed by a medical profession, either a doctor or a pharmacist or anyone, given period of time. So let's say 2 times 1 is a dosage. It means that you'll take 2 tablets once in a day. So it's over a given period of time. But you can say to be taken at a given period of time also, not over at a given time. Okay, at a given period of time. I think much likely this, if I put it this way, is going to be understandable. So it's the prescribed amount of drug to be taken at a given time. So that is question 2 done. But let's say also prescribed amount by a medical professional. So isiwe ni mtu ambao ni zumbukuku tu anakuambia uchukue dawa mara 2 au mara 3. Professional. Okay, so let's continue with question 3. Okay, this looks like an atom. In laboratory practical, students observe a substance made of identical particles. Define the term atom. Now, an atom is the smallest particle of an element. So it's the smallest particle of an element. It's the smallest particle of an element that can take part in a chemical reaction. in a chemical reaction. As long as it's the smallest particle of an element can take part in a chemical reaction. When a reaction takes place, then the atoms are usually the ones that are reacting. Atoms of this element reacting to another element. So in a chemical reaction. Okay. Question 4. A teacher writes the following elements on the board, which is sodium, and A represents for sodium, 23 and 11. Now we say that if you have an element X and there's A and there's B, the superscript represents the mass number, okay, and the subscript, which is B, represents the atomic number. So if you look at the superscript, this is the mass number, and this one is your subscript, which is the atomic number. So identify the atomic number of sodium. It is 11. Question 5. In a classroom discussion, learners compare atomic models. State one main feature of the Rutherford atomic model. So one of the features that I may say, the mass of an atom is usually concentrated in the nucleus. It's concentrated in the nucleus. So the mass of an atom is gotten from the nucleus itself. So as a result, is usually concentrated in the nucleus of an atom. That's something that you should know. It's mainly concentrated in the nucleus. The other part that I might say is an atom. Obviously, an atom has a densely positive charged nucleus. Has a dense positive charged nucleus. Positively charged nucleus. Okay. And also it's surrounded by electrons and etc. So that's the other part. Okay. Question 6. A chemistry teacher demonstrates the arrangement of electrons in atoms. Give the electronic configuration of neon. Now, if you look at neon, if you look at the mnemonics, hey, listen, BBC News on Friday night, neon is at number 10. Now, number 10 means it has an atomic number of 10. So, atomic number of 10, it also means that the number of protons will be 10. And now, if you have 10 protons in an electrically neutral charged atom, the number of protons is the same as the number of electrons. So it also have 10 electrons at the end of the day. So neon having 10 electrons, you'll write the electronic configuration as 2, 8, because the first energy level usually takes 2, the second energy level usually takes 8 electrons. That's the answer to this question. But I think there's also the S and P. If in case you've been asked to write it in terms of S and P, if it is in terms of S and P, then it's going to be written as 1s squared, then 2s squared, then followed by 2p6. Usually the s orbital usually takes a maximum of 2 electrons, then the 2s also takes a maximum of 2 electrons, and the 2p orbitals usually take a maximum of 6 electrons, giving you 10 electrons. So this is in terms of S and P. And I think you guys will be taught about S and P. You rewrite something like this. You have this way, and you get this something like this at the end of the day. So yeah, it's not that hard. It's very easy. But let's continue. Question 7. During a revision class, students are asked to classify elements. Name one group of elements that are chemically unreactive. So one group of elements that are usually chemical unreactive are the group 8 elements, which we call them as noble gases. So all the noble gases are reactive and unreactive, like neon, helium, and etc. Question 8. In a hospital pharmacy, drugs are dispensed. Carefully state one effect of drug abuse on the human body. First effect that you're going to have is addiction. You'll get addicted to that drug every time and you won't be able to to leave it. The second one is maybe health issues. You might get health issues. Second one, maybe you might have hallucinations and etc. But there are many effects of drug abuse. It might affect your health. It also can lead to brain damage, especially drugs like heroin or something like that. And we also have organ failure, poor health, and etc. So, for example, you have alcohol. Alcohol can lead to liver cirrhosis. So, question 9: a student performs an experiment on chemical bonding. Name the type of bond formed between sodium and chlorine in sodium chloride. Remember that we have 3 bonds. We have the first bond called ionic bond. Ionic bond is between a metal and a nonmetal, like for example sodium and chlorine, or potassium and chlorine, or potassium and iodine, or potassium and maybe fluorine, magnesium and chlorine. As long as it's between a metal and a nonmetal, then ionic bond is usually formed. We also have covalent bonds. Covalent bonds are mainly between nonmetals. So nonmetal and nonmetal. So that's when covalent bond is formed. Now for ionic bond, a bond is formed where one atom loses an electron and the other atom gains an electron. For covalent bond is formed when maybe one or both of the atoms are sharing those pair of electrons. Okay, so it leads to sharing of electrons rather than losing or gaining. Then the third one, we also have metallic bond. Now under covalent bond, we have a very special bond called a divalent bond. We have a bond called the coordinate bond, okay, where one of the atom is sharing and is donating to the sharing pair of electrons. So they much likely donating. So, but they're sharing the donated pair of electrons. Now, the type of bond, since it's between a metal and a non-metal, so that bond is called ionic bond. The structure that will form from ionic bond is called giant ionic structure. Question 10. In a lab, learners are given 2 isotopes of chlorine. There is chlorine with a mass number of 35 and another chlorine with a mass number of 37. Now, define the time isotopes. Isotopes are atoms of the same element. Okay, like for example, these are atoms of the same element with different, if you look at it, it has different mass numbers, or with different mass numbers but same atomic numbers. Okay. Now question 11. During an exam discussion, a teacher writes the hydrogen plus oxygen, you get water. Now state whether this equation is balanced or not. Let's see. Now in an equation, we have the reactant side and also have the product side. The product side is on the right, which is this, and the reactants are H and O, which is hydrogen and oxygen. Now let's see. Whatever you find at the reactant side, you'll also find it at the product side. So you'll have H and O as well. Now, how many hydrogens do you have? We have 2 hydrogens on the left side. No, not 2 hydrogens. We have 4, because here is 2, and then you have 2. 2 times 2 gives you 4 hydrogen on the left side, and we have 2 oxygen on the left side. If we look at the right side, we have 4 hydrogen, because 2 times 2 gives you 4, and we have 2 oxygen. So if you look at it, it's balanced. So state whether this equation is balanced or not. Yes, it is balanced. Very simple question. Question 12. A learner studying the periodic table identifies elements in the same vertical column. State the name given to vertical columns in the periodic table. So let's say if this, I'm just drawing a sketch. So let's say if this is your periodic table, then basically you get something like this. It's just an example. is not the real periodic table. So you get something like this. Okay, there's a transition method here, so that's why I didn't draw it, but you get something like this. Now the vertical columns are usually groups, so group 1, group 2, still group 8. Now the rows are usually periods, so this is the row 1, row 2, so row 3, so it means period 1, period 2, period 3. Now the vertical columns are called groups. The horizontal rows are called periods, but for this question it's groups. So instead the name given to vertical columns in the periodic table, we call them groups. Question 30. During a lab safety lesson, students learn about gases. Name one gas produced during combustion of hydrocarbons that contributes to global warming. Now if you take a hydrocarbon and react it with if you combust, it means it's going to react with oxygen. You're going to get carbon dioxide. Don't call it carbon dioxide anymore. So carbon dioxide and water. So plus water. Okay. Even if you take, let's say this is methane, which is a hydrocarbon, you react it with oxygen, you get carbon dioxide plus water. So that's the main product. Now this carbon dioxide is basically the one that usually contributes to global warming. So basically this is the gas that is carbon dioxide. If you write methane as well, you're correct. Also correct, because some methane might not react and you just leave it in the atmosphere. So that. Question 14. A learner analyzes atomic structure. State the charge of a proton. A charge of a proton is basically +1 always. So it's a positively charged subatomic particle. Question 15. In a lesson, and also electron is usually -1, is a negatively charged electron, and neutral is usually 0 because it's neutral. Now in a lesson on bonding, students compare structures, and we say the types of structure. We have giant ionic structure, okay, ionic structure. We have simple molecular structure. We have simple molecular structure. What else? What structure do we have? Simple molecular structure, giant ionic structure. We have giant atomic structure or giant molecular structure. So we also call it giant molecular structure or giant covalent structure. And last but not least is giant metallic structure. But for this question, it's very different. Now, in a lesson on bonding, students compare structures which bond type allows electricity to pass through molten sodium chloride. So if you look at sodium and chlorine, it's basically an ionic bond, and ionic bonds usually, this is an ionic bond. So the bond is called ionic bond. Why it conducts electricity? Normally, ionic bond conducts electricity because of free mobile ions, and the ions become free because of free mobile ions in aqueous or molten state. So if it's molten, then it can conduct electricity, or if it's in aqueous state. But in a solid state, it never conducts electricity. Now, question 16. A teacher discusses careers in chemistry. Name one career related to chemistry. Teaching. What am I doing? That's a career. Okay. Or you can have, you can tend to be pharmacist. Doctors also, because one of the prerequisites of studying doctor is either you have a B plus in biology or also B in chemistry, right? So pharmacist, you can be a chemist, you can be a lab technician, okay? Lab technician, you can be a chemical engineer, and etc. So I've not told you not one, not two, but 5. Okay, question 17. During a discussion on substance abuse, learners mention banks. state one effect of bang on the human brain. Hiyo ni kawaida, hallucination. Watu ambao wavuta bangi wa hallucinate, mara waona watembea uchi, mara kuona uko Dubai, wenyewe pia wajiona kama hawako Kenya. Mtu wampata pale mtaani, vipi mwana, sahihi saa ngapi? Haijafika asubuhi, na kumbe ni bado tuko saa 4 za usiku, na yeye akili yake tayari yaona mwangaza. Okay. But this one effect is hallucination. You also get addicted, and also impaired memory. And this is something that you should know. Impaired memory, mtu wa kusahau sana. Kuna shida na memory. Jana ulikutana na yeye, kesho atakuruka, atakwambia tulikutana na wewe lini? Mtihani. That is why always abstain drugs. If you're using drugs, abstain from today, because once you get into it, you become addicted, and once you become addicted, ndo kuisha. Kuregea being normal is going to be very hard. So if possible, I'm not only a chemistry teacher, I'm also a mentor. That is why I opened a YouTube channel for you guys. Okay, question 18. In a chemical reaction lesson, students observe a reaction releasing heat. Now, what type of reaction is this? Now, this type of reaction is called exothermic reaction. Endothermic is when you absorb heat. Okay, exothermic is when you release heat to the surrounding or to the atmosphere. So it's called a exothermic reaction. Exo means outside. Endo means inside. So endo is basically absorption of heat. Okay. Exo means releasing of heat. Okay, let's go to question 19. Alana studies orbitals. Name the orbital that can hold a maximum of 2 electrons. And you said it is the s orbital. The p orbital holds a maximum of 6. And there's the d orbital, which holds a maximum, I think, 14, if I'm not correct, if I'm not wrong. Okay, the d orbital, did I say? No, the d orbital holds 10 electrons, a maximum of 10 electrons. The f orbital usually holds, if I'm not wrong, 14, a maximum of 14 electrons. Okay, so sorry for that. I think it's because of the drug. Okay, question 20. I'm not a drug addict, sorry for that also, if you thought I'm one. So question 20. During a lab session, students study periodic trends. State how atomic size changes across a period from left to right. Let's say if you have 281, across the period is going to be 282, 283, 284, and etc. Now you've just been told to state how atomic size changes, and atomic size usually reduces. So it reduces across a period. And why does it reduce? The reason is very simple. This is because as you go across the period, protons increase. And if protons increase, the nucleus becomes more positively charged. And it means you're increasing the number of magnets in the atom. So the electrons will be drawn towards the nucleus. So if your energy level is like this, it will be drawn towards the nucleus, becoming smaller and smaller. So the more protons you have, the smaller your atomic size is. Question 21. A student compares metals and non-metals. Name one property of metals. Now, I can name many properties. Metals are ductile. Okay, they are malleable. Ductile meaning that you can turn it into thin wires. It can be drawn into thin wires. Okay, malleable means you can crush it. Okay, you can hammer it into thin sheets as well. That's malleability. And most of the time, metals are very, very strong. Okay, they are good conductor of electricity. All the metals are good conductors of electricity, maybe apart from mercury, but most of them are good conductors of electricity. And as well, they are lustrous. What does lustrous mean? That's a homework for you to research on. I want you to tell me on the comment section, what is this mean? Hata nimeandika vibaya. It's supposed to be this way, lustrous. So what does this mean? Okay, comment section. Students, tell me please. Now, in a class experiment, a solution conducts electricity. State what type of compound is present. We said it's called what ionic compound. So it's an ionic compound, or if you write an electrolyte, you're also correct, because electrolytes usually conducts electricity. So now ionic compound is said when you dissolve it in water or it becomes a solution. So if it's in solution form or in molten form, then it can conduct electricity. But in solid form, ionic compounds do not conduct electricity. For metals, it can conduct even when it is in solid, solution, or molten. Now, question 23. Alana identifies a molecule with shared electrons. Now, we've said anything dealing with shared electrons is about covalent bonds. Name the type of bond formed by sharing electrons. Now, the reason the answer is covalent bond, and the reason why it's covalent bonds is because covalent bond is more about sharing electrons, and this is because it's consisting of nonmetals. And now, if you look at nonmetals, if you have a bond between a nonmetal and a nonmetal, and all of them need to gain, so you can't say ati huyu atoa huyu atagain. No, because all of them gain, they usually share the electron, so they donate by way of sharing. Mimi nikikupa wewe pia unipa, ama mimi nikupe zote mbili, but still we will share. It's not like the ionic bond where a metal loses and the nonmetal gains the electron. So one loses and the other one gains. But for covalent, even though one might donate, you can still, he's opted to share. So lazima ata share. Question 24. During a revision session, students balance equation. What's the total number of atoms of oxygen in H2O? I think it's just 2. Am I tripping? It's just 2 atoms. Ukiangalia hapa, you have 4 atoms of hydrogen and you have 2 atoms of oxygen. Ukiangalia tu vizuri, this 2 yaenda kwa oxygen, so it's 2 atoms of oxygen, and you also have 2 times 2, which is 4 atoms of hydrogen. Now, question 25. A student studies the noble gases. State one characteristics of noble gases. Just likewise, all noble gases are unreactive. They do not react. So that is something that you should know. They are chemically unreactive, or they're unreactive, whichever way. And you can use them. You can use. They have full outer shell because they're unreactive. They have full outer shell. That is why they are unreactive. So lazima, if it is, let's say for example, we have helium. Helium ni 2. Called electronic configuration is 2. We have neon, which is 2,8. So it means that obviously it has full electrons either in duplet state or in an octet state. So it neither can gain or lose. Question 26. A teacher demonstrates oxidation. Define oxidation in terms of oxygen. Now, the oxidation means addition of oxygen. Okay, that is oxidation. So addition of oxygen. So for example, we have lead and you're reacting with oxygen, you get lead oxide. So what happened here? Oxidation occurred because you've oxidized lead to be lead oxide. So that is oxidation. Or you can have a situation where one is zinc. You have zinc reacting with copper oxide. So what happened is zinc gets oxidized to zinc oxide because zinc is more reactive than copper, and copper gets reduced, so it undergoes reduction, but zinc undergoes oxidation to be zinc oxide. So that is oxidation, addition of oxygen in an element. Now, question 27. During a lab test, a student identifies ions. Now, state the charge of a chloride ion. Now with that, we know that chlorine, the electronic configuration, because it's under number 17, it's the electronic configuration is 287, and since it is 287, it means that it gains 1 electron. Okay, if it gains 1 electron, it also means that it will have 1 more electron and then the protons. So, and that is why chloride ion, when it forms an ion, it will gain an electron to form chloride ion, which is written as chlorine minus. Okay. Question 28. Alana studies chemical symbols. Write the chemical symbol for aluminium. Now this is how we write aluminium: capital A, small l. And many students usually write it this way, which is very wrong. So I don't know if that L is a small l or a capital L. So an L is a small, there should be a small l like this. If it's copper, capital C, small u. Okay, and don't write this way. Now I don't know, this is the U, is it capital or a small c? So it looks like a capital U, but all in all, I think you've understood a capital C and a small u that way. Which common mistake that many students do? I think that one is the common one. If I remember, I'll tell you, maybe in this video or in the next video. Question 29. In a classroom debate, learners discuss drug abuse causes. Now state one cause of substance abuse amongst youth. Okay, one cause is peer pressure. Watu who influence, especially your friends, are the main problem. If you have a bad friend, just abstain away from him. It's like your 4 friends. Let's say you are 4 friends. Okay, the first friend is an idiot, the second one is also an idiot, the third one is an idiot. You being the 4th one will also be the average of all the 3 idiots there. So it'll be like extra potential idiots. It's better to be away from bad friends. It's better also to have few friends which can benefit you rather than having many friends that don't benefit you at all. The second one is curiosity. Curiosity killed the cat. So wewe kama kijana wataka kuona, yani uko na jazba, bangi ya kiti vipi, ukivuta yatoa moshi ama yatoa nini, barafu. So that is curiosity. So that those are the main causes, by the way. Wanafunzi wengi they are very curious. Utakuona bangi ya kiti vipi, ni ndefu, ni ndogo. Okay, so curiosity kills the cat. The more curious you are, the more you will kill yourself, my friend. So leave that alone. Also stress. Lakini sahihi stress ya nini majamani? Hata hamjaoa, hamjaolewa, hamna wife, you don't have anything, what's the stress for? That's something that also I don't understand. Fourth one, maybe family influence, especially, and this is very very sad. Yani utapata yani babako yavuta bangi, mamako pia yuko katika hiyo chama, especially ukija Mombasa, mashallah, yani wote yani wako katika familia uraibu. Mama yachonga miraa, baba yachonga miraa. Sasa kila usiku ikifika wote wachonga maso, mpaka waita mtoto, njoo Amari, njoo chonga, alafu watuma watoto wao dukani wakanunua big na sigara. Subhanahu wa nas. Question 30. A student studies hydrocarbons in daily life. Name one use of hydrocarbons in everyday life. It's used in treatment of cancer. If you know, used in treatment of cancer. No, that's an isotope. Isotopes are used in treatment of cancer. For hydrocarbons, we use it in fuels. Okay, especially the ethanes, the methanes, the butanes. We use them in fuels. Katika petrol and etc. Okay, we can also use them in gas cookers, especially butane. We can also use them making plastics. You have something called polymers. So polymers, just as plastics, polyethylene, polythene bags, they come from hydrocarbons. Now let's go to section B now. Section B. Answer all questions. I'm also feeling tired, but all in all, no problem more. During a laboratory investigation in Lenana Senior School, students especially, I want papers from Lenana. If you're in London, Lenana, please send me on this number. Again, I'm thinking of starting tuition classes for grade 10. If you see, should I start one or shouldn't I start one? Shouldn't. If you see, if you think it's better for me to start grade 9 classes, then comment on yes. If no, then comment no. Okay. Grade 10. During a laboratory investigation in Lenana Senior School, students analyzed the structure of the atom using the following diagram. Identify the subatomic particles labeled P+, N0, and E minor. So this is obviously protons, positively charged subatomic particles. This is neutrons, neutrally charged. Okay, and these are electrons. 3 marks za bure ushapata hivyo. Okay, because this is the nucleus. The nucleus kuna protons and neutrons, and this is the energy level, and we just have electrons around it. Explain the role of the nucleus in an atom. Okay, this is where this is where most of the mass originates. Okay, so first thing, it concentrates protons and neutrons. Yani you keep the protons and neutrons. That's the first one. Second one, maybe controls the atom's mass, because most of the mass comes from the nucleus. It doesn't come from the electrons. The atom's mass. And third one, maybe holds positive charge because of the protons. Chap. Now, a sample of chlorine contains isotopes 75% of mass 75% of mass 35 and 25% of mass 37. Calculate the relative atomic mass of chlorine. So if you want to calculate, obviously you take isotope 1, okay, times by its percentage abundance, plus isotope 2, that is the mass of isotope 2, times by its percentage abundance, divided by 100. So the isotope 1 is 35, multiplied by its percentage, which is 75, plus 25 times, okay, let me write here, 37, which is its mass, times 25%, divided by 100. So yep, how much will it give us? 35 times 75 plus 7 times 25 divided by 100 gives us 35.5. Kama dawa. Now, state one use of isotopes in medicine is used to treat cancer. So treatment of cancer. So usije ukaenda kutafuta sijui isotopes if you don't have the knowledge of chemist or pharmacist. Don't do that. Question 32. Okay. A learner studies the first 20 elements in the periodic table and is given that this way. Okay. Element X, atomic number 11. Write the electronic arrangement of element X. So it's going to be obviously, if it's atomic number 11, then the electrons will also be 11, because this is protons, and protons is equal to electrons as well. So 11 electrons. So obviously it's going to be 2, 8, 1. Ikiwa ni S and P, I think it's going to be 2s2. Is it 2s2? It's supposed to be 1s2. Okay, in terms of S and P, is going to be 1s2. Okay, it's going to carry 2, then 2s2. So those are going to be 4 electrons. You remain with 7 electrons. Then we have 2p6. So those are 4 electrons. And then we have 3s1. So yeah, that's electronic arrangement in terms of S and P. This is the normal one that you should know, but you can, I don't know if you're allowed to write both of them. but if you write this one, you still get marks. Question B, identify the group and period of element X. Now the group is group 1. You look at the outermost, what's happening now? You look at the outermost energy level. So if you look at the outermost energy level, it's supposed to be group 1. Okay, so group 1, write it in Roman number, period 1, 2, 3. So you look at the energy levels. If it has 3 energy levels, obviously it's going to be period 3. Write it in terms of numbers. State 2 characteristics of alkali metals. Now alkali metals, they are soluble in water. That's something first thing that you should know. Alkali metals. Now alkali metals are very soluble in water. They react with water. Okay, especially sodium, potassium, lithium react with water. Okay, the other characteristic is that they're highly reactive with anything, especially oxygen or water. But since I'm writing reactive, I think let me just ignore this. But it's usually reactive. So they are soft metals. Sodium is a soft metal, is a soft ball. Potassium as well, and etc. Okay, I think that is that. But it's usually also highly reactive. In case I don't prefer you to write reactive, reacts, write something different. Now also conduct electricity. Question D, explain how electron arrangement determines chemical reactivity. Okay, chemical reactivity. Now chemical reactivity, as for the electron arrangement, it depends on the outermost electrons. So most of the time depends on the outermost electron, okay. So on the outermost electron, elements with incomplete react easily. Okay, elements with incomplete outer shells react easily. Incomplete outer shells react easily. What do I mean by saying that? So let's say, for example, you have 2A2. Hapa kuna incomplete electrons, because you need to react to add to lose 2 so that it can become 2,8, so that the outer shell becomes full. So ikiwa ni full like 2,8, it doesn't react. That is why it's unreactive. But here ni kama 2,1, 2,2, 2,8,2, 2,8,3, as long as the shell is not full, then it can react easily. Now question E, so the metals, they say for the metals from group 1 to 3, especially like sodium to H1, magnesium to H2, they usually react by losing electrons. For non-metals, which are group 5, 6, 7, they for example, chlorine, which is to A7, it reacts by gaining. So yep, so it depends on incomplete outer shells. So question is, a student observe sodium reacting with chlorine. Identify the type of bond formed. We say metal and non-metal is ionic bond. I think this is the 4th time it's asking. Question 33. During a practical lesson, students compare bonding in diamond and sodium chloride. State the type of bonding in diamond. So the type of bonding is just covalent bond. Okay. So diamond usually has a giant covalent structure. Okay, that is because the carbon atoms are usually bonding with each other with the help of covalent bonds. So it has carbon atoms, and obviously they are non-metals, and carbon atoms bond with one another to give you now a structure like diamond or graphite. So sodium chloride is giant ionic structure. So the bond that is there is ionic bond. Okay, but the answer to this first question is covalent bond. Question B, explain why diamond does not conduct electricity. Very simple, because it does not have a delocalized electron. have any delocalized electron. Otherwise, if you could have, then it could have conduct electricity, and this is because it uses all of its electrons in bonding. So there's no electron that's remaining to conduct electricity. So it uses all of its electrons in bonding. The 4 electrons that it has, it conducts as used in bonding. Question 34. A learner performs a reaction between hydrogen and oxygen in the laboratory. Now balance the equation that we have, the first one, the second one, the third one, and the fourth one. Okay, let's balance it. The first one is chlorine plus sodium hydroxide, giving you sodium chloride, sodium hypochlorous, and water. Okay, so this is sodium chlorate, not hypochlorous, sodium chlorate plus water. How do you balance this type of equation? Now you look at everything. Look at chlorine, look at sodium, look at hydrogen, look at oxygen. Right, now let's look at everything. Now we have sodium, we have chlorine, we have oxygen, we have hydrogen on the reactant side. Let me write it here. Sodium, chlorine, we have oxygen, we have hydrogen. And on the product side is also sodium, chlorine, oxygen, and hydrogen. We have 1 sodium here, and we have 2 sodiums here. So you've seen it already. They are unbalanced on parts of the sodium. We have 2 chlorines, and we have 2 chlorines here, which means the chlorines are balanced. The chlorine atoms are balanced. We have 1 oxygen. We also have 1 oxygen. No, 2 oxygens. Also means the oxygens are unbalanced. So, and then hydrogens, we have 1 hydrogen here and 2 hydrogen here. So the main ones that are affected is the sodium, and you also have 2 hydrogens here, and the ones that are affected is sodium, oxygen only, mostly sodium and oxygen. Let's say we can put 2 here on sodium, and it change to 2 sodiums, 2 oxygens. Chlorine will just remain the same, and 2 hydrogens. Sorry, hydrogen was 1 here, so 2 hydrogens. So it means it's balanced now. So yeah, so that's how it's balanced. Just put 2 in the sodium hydroxide, and it becomes balanced. How about Roman 2, chlorine plus potassium hydroxide plus potassium chloride plus potassium chlorate plus water. So the same thing, potassium, chlorine, oxygen, hydrogen, as well as potassium, chlorine, oxygen, and hydrogen. Potassium, we have 1 potassium here. On the left and the right side, 2 potassium, 2 chlorines. We have 2 chlorines as well. 1 oxygen. We have 1 oxygen. Oop, we have 1 oxygen. Very, very tricky now. We have 1 oxygen on the left hand side. We have 3 oxygen. We have 3 or 4. We have 4 oxygens on the right hand side. And then we have 2 hydrogens. So the one on the left side, we have 1 hydrogen. On the right side, we have 2 hydrogens. So this is the main affected area: oxygen, hydrogen, and as well potassium. Let's say if we put 4 here, then it means it's going to affect but let's see. It's going to mean 4 potassium, 2 chlorine, 4 oxygen, but also 4 hydrogen. Okay, this affects the what if now this will confuse me a little bit, somehow very tricky. Since, okay, let's say we put 2 here, because of hydrogen. You'll have 4 hydrogen, and now you'll have 5 oxygens, which is now giving us a tricky part: 2 chlorine, 2 potassium. Now what if I put 3 here to give you 4 potassiums, but 3 chlorine, 4 chlorine by the way, but 9 oxygen. 9 plus 2 is going to give you 11. Okay, let's wrap this all, otherwise we get confused. Hey, let me wrap this. Now the main part which is affected is the chlorine. Now it's the potassium, right? Is the potassium. What if I put 5 potassium here? Okay, if I put 5 potassium, it's going to be 5 potassium, 5 oxygen, 5 hydrogen, and now the hydrogen gets affected. So what if I put 6? Yeah, it's going to be 6 potassium, 6 oxygen, 6 hydrogen. Okay. The 2 chlorines. So okay, so what if I put 5 here? So it's going to give you 6 potassium now, 5 chlorines, no, 6 chlorines, 5 oxygen, and 6 hydrogen. That is still, you're going to get 2 hydrogens. How many oxygens are there? Still 4 oxygens. Very tricky. Okay, now let me put 3 chlorines here. There's going to be 6 chlorines, because there were 6 chlorines. That is why I put 3 here to give you 6 chlorines as well. But what happens to the oxygen now? What if we put 3? So it's going to be 3 oxygen here, 3, which gives you 6. So yeah, it's balanced. Come on, already balanced. Ooh, balanced now. Alhamdulillah. Question Roman 3. You have iron 2 chloride and plus chlorine to give you iron 3 chloride. So what do you get from, how do you balance this, by the way? Okay, we have iron, we only have chlorine, we have iron and chlorine only. So 1 iron, 2 chlorine, not 2 chlorine, 4 chlorine because of this and this, and then we have 1 iron, 3 chlorine. So what happens? We can put 2 here. They'll have 2 ions, 4 chlorines, and 4 plus 2, 6 chlorines, right? Then we can put 2 here. Then we have 2 ions and 6 chlorines, balanced. Khalas. Question of 4. Now question Roman 4. Also, let's balance this, which I'm going to get a headache today on balancing. But is it balanced? I think it's balanced, by the way. You have 1 magnesium, 1 magnesium, 1 sulfate, 1 sulfate, 1 copper, 1 copper. So you don't need to balance it. It's already balanced. So you don't need to add anything there. Define valency. Okay, define valency is the capacity, or is the combining capacity of an element. So that is valency, or is the ability of an element to either lose or gain. Okay, but it's just combining capacity of an element. Okay, determine the valency of oxygen in water. Now oxygen in water. Oxygen, by the way, is number 6. So it means it has 6 electrons. It has an electronic configuration of 2, 4. So the ability to, it can obviously, is it 2, 4? Is it number 6 really? No, oxygen is not number 6. Hey, listen, BBC News on is number 8. So it's written as 2, 6. So it has the ability to gain 2 more electrons. So it's going to gain 2 electrons. So the valency is, for it to be stable, it's going to gain 2 electrons, and the valency is 2. Write the formula for compound formed between calcium, which is valency 2, and chlorine, which is valency 1. So calcium is written like this, valency 2 meaning 2 plus, and chlorine, which is written like Cl minus. So calcium gets the valency 1 to give you Ca, and chlorine gets the valency 2 from calcium to give you Cl2. So that is how we write it. Okay. Explain the importance of valency in chemical bonding. So it determines bonding first thing, because without it you can't know. So it determines bonding. It will help you how many atoms should react with how many atoms of another element. So it determines bonding, and it helps to give you, it helps in forming correct chemical formula, helps in forming the correct just like the previous question, the correct chemical formulae. Okay, question 35. The diagram represents a part of the structure of sodium chloride crystal. The position of one of the sodium atoms in the crystal is shown as this one. On the diagram, mark the positions of the other 3 sodium ions. Okay, where is it shown? I'm not seeing anything. So most probably, I think it should be surrounded. This is the first one. Should be surrounded by 4. 1, 2, 3. Let me see. It should be surrounded by 3, by the way. So this is minus. This is minus. This is minus. This is going to be plus. Plus, minus, minus. This is plus, and this is plus. So yeah. So the plus signs are here. Those are your plus signs. Okay. The melting and boiling points of sodium chloride are 801 degrees and 1413. Now remember, the plus signs here, if I forget, is because of for every plus sign is usually surrounded by negatives. That is why imechora hivyo. So don't get confused. The melting and boiling points of sodium chloride are 801 degrees Celsius and 1413 degrees Celsius respectively. Explain why sodium chloride does not conduct electricity at 25 degrees Celsius, but does not at temperatures between 801 degrees Celsius and 100 what? But does not. So anyways, but does at temperatures between 801 degrees Celsius and 1413 degrees Celsius. This is because giant ionic structures, especially like sodium chloride, they conduct when in molten form. Conducts when in molten form, that is when it's at 801 degrees Celsius and 1413 degrees Celsius, but not in solid form. But not in solid form. That is at 25 degrees Celsius. Okay, because in molten form the ions are usually mobile, but in the solid form they're usually fixed. They do not move, so they are in fixed state. So the particles are in fixed states, and they cannot conduct electricity in that form. Give a reason why ammonia gas is highly soluble in water. That's very easy, because it forms hydrogen bonds with water, and it's polar. So it forms hydrogen bonds with water. So it bonds with water. Very simple answer. So ammonia is polar, so it gets attracted to the polar part of water. The structure of ammonium ion is shown below. Name the type of bond in the diagram. This one. Okay, so this is a divalent bond, or you can say covalent. Not covalent, it's called coordinate bond. It's called coordinate bond, not divalent. It's called dative bond as well, or dative bond, whichever name that you'd say. Now this one, it means that huyu jamaa alikuwa na electron, because let's say nitrogen imesaidia hydrogen, and the other hydrogen also helped nitrogen. So one donated, one also donated, here also one donated, one donated. So because nitrogen is 2,488 P PC news 2,5, so it requires 3 electrons to be full. So it requires 3 electrons. So it uses obviously 3 electrons with bonding. It bonds with nitrogen, so it uses 3 of its electrons. It's going to remain with 2 electrons. Now that 2 electrons ambazo imbakia itampa hydrogen, and this hydrogen is H+. H+ yamaanisha it doesn't have electrons in it. Okay, so if it doesn't have electrons, so it's going to receive all the 2 electrons from nitrogen and they will share. So that's the arrow. Hii yamaanisha nitrogen imempa 2 electrons and they're sharing those 2 electrons. So the nitrogen is the one who donates the share pair of electrons. Question D, carbon exists in different crystalline forms. Some of these forms were recently discovered in soot and are called fullerenes. What name is given to different crystalline forms of the same element? Right, say of the same element. Okay, we call those allotropes. Very easy. Allotropes are different structural form, but the same physical state, if I'm not wrong. And there are different allotropes. We have graphite, we have diamond, okay, of carbon, we have fullerenes, and etc. Fullerenes dissolve in methyl benzene, okay, well the other forms of carbon do not. Given that soot is a mixture of fullerenes and other solid forms of carbon, describe how crystals of fullerenes can be obtained from soot. So what you need to do, first thing, is very simple. You add the solvent or methyl benzene into soot in a beaker. Okay, once you add it to soot in a beaker, you then shake and filter. So doing that, you shake and filter. So after shaking and then filtering, you warm the filtrate. Okay, you warm the filtrate to concentrate it, or you warm the filtrate to saturation. Whichever one that you might think is the best, then you can write it. So you can warm it to concentrate it or to saturation. Okay, and then after doing that, allow the concentrate to cool. Allow the concentrate, the saturated solution, that is the concentrate, to cool and form crystals. To cool for crystals to form. That is that. And then filter to obtain now crystals. Filter, or remove the mother liquor. Filter to obtain crystals of fullerene. Fullerenes. Now the reason why my sound looks like this is because I'm tired. I've been teaching from the start to the beginning, but I think we're very near, or we're approaching to the end of this video. Now the relative molecular mass of one of the fullerenes is 720. What is the molecular mass of this fullerene? Which is very easy. Molecular mass of this fullerene, remember carbon is 12. Okay, it has a RAM of 12, so you're just supposed to do 720 divided by 12, and it's going to give you 60. So yeah, molecular mass is 60. That's why it's called C60. Okay, question 36. Explain the following observation. Sodium chloride allows electric current to pass through them in molten state. This is because of free mobile ions. This is because of the free mobile ions in molten state. Okay. Graphite is a metal, yet it is a conductor of electricity because it has a delocalized electron. And this is caused it uses it uses 3 of its electrons in bonding, leaving 1 electron to be delocalized. So let's say this is carbon. So this is carbon. So it combine 3 carbon atoms. So it leaves 1 electron in bond in conductor electricity, but the other electrons are used in bonding. Study the table below and answer the questions that follow. We have a melting point of A, B, C, D, E, F, boiling point as well. Electrical conductivity of A. I'm not even this is in solid state, this is in liquid state. For A, it's poor in solid state but good in liquid state. B is poor, so this means it's simple molecular structure. This means it's ionic structure. This is metallic structure, and the others are simple molecular structure. Okay, Roman 1 have a metallic structure, that is C. Okay, it is C, and the reason is because it conducts electricity in both molten and solid state. Conducts electricity in both molten and solid state, and I think we've discussed about that. Roman 2 have a molecular structure and exist in the liquid state at room temperature and pressure. That is room temperature and pressure. So it's a simple molecular structure but exists like a liquid. So anything above 25 degrees Celsius is normally liquid, especially when it is what do you say it when it's very near. So basically its melting point is below room temperature if it's liquid, and above room temperature. So room temperature is 25. So the one that is usually above and below, so is below the room temperature, below 25, and it's above the boiling point, is above the room temperature, and therefore this is the answer. So D. Okay, because melting point, I'm just writing in abbreviation, don't write it like this, let me just write it, najua akili ya wanafunzi, because melting point is below room temperature and boiling point above room temperature. Suggest why substance B has 2 melting points. Which substance B has 2 melting points? Oh, it has 113 to 119. Okay, it can exist in allotropic form. It can exist as allotropic form. That is why it has 2 melting points. There is upon diamond, there is upon graphite. So it exists in allotropic form. That is why it has 2 melting points. Roman 4. So these are different structural forms. That is why one substance can have 2 melting points. Like for example, carbon. It's going to be either in diamond or in graphite, and the melting points of each of them are very different. Substances A and C conduct electric current in the liquid state. State how the two substances differ as a conductors of electric current. A and C. A and C. Oh, A and C. This is now A and C usually conduct electricity in molten state, but C conducts in both solid and molten state. Okay, but A conducts because of mobile ions, and C conducts because of the localized electron, not because of mobile ions. Very simple. We're very near, hopefully. The grid below represents part of the periodic table. The letters do not represent actual symbols of the elements. State and answer the questions that follow. Okay, what type of bond will you expect in the compound? So remember, this is group 1. Let's just write it. 1, 2, 3, 4, 5, 6, 7, and 8. And we have period 1, 2, 3, and 4. So what type of bond will you expect in the compound formed between H? Where's H? I'm not seeing H. I think one of them is H. H. I think this is H. I'm not wrong. And this is F. Okay. H and F. So what type of bond is that? Ionic or electrovalent bond. So you can call it any, because it's between a metal and a non-metal. Group 1 elements are metals, group 7 elements are non-metals. H is a group 7 element, which is a non-metal. F is a metal because it's group 1 element. Now, which of the elements J and M will have a greater atomic radius? J and M. J and M. So J will have a giant atomic radius. J has a giant atomic radius, and we've already studied this. Ionic atomic radius. We studied this. Atomic radius usually decrease across the period, and this is because J has fewer protons. Okay, J has fewer protons. Okay, I think that is easy. So J has fewer protons, so it means that it's going to have less pull. So, or let's say the energy level. How do I answer it? So it's going to experience less pull. Or the energy level or the electrons are going to experience less pull towards the nucleus. That is why it's bigger. Elements F and N are in the same group of periodic table. How do their atomic radius compare? F and N. Where's F and N? This is F, this is N, right? Now N has a larger atomic radius because it has more energy level. Does it have more? Yeah, it has more energy levels than F. So if group 1 elements, if you want to know which one is larger, you just look at the energy levels. More energy levels than F. Because let's take an example. Let's say 2,1, that is what is that? Lithium, and we have sodium, which is 281. Now this one has 3 energy levels, and for lithium it has only 2 energy levels. So it means sodium has a larger atomic radius because it has more energy levels than lithium, just from the drawing. So this is lithium and this is sodium. So you see, the more energy level it has, the larger its atomic radius. An element W has atomic number 15. Indicate the position it will occupy in the table above. Atomic number 15, so it's going to be 15 electrons, and therefore it's going to be 285. So group 5, period 3. Right, group 5, period 3. So group 5, which is here, period 3, period 1, 2, and 3. So what do you call that? Element W. So element W would be here. Okay, this is because, let me write using a different pen, and let me finish with this blue pen now today. Group 5, period 3. What's the name given to elements X to Z? X to Z are called transition metals. Okay, very, very easy. Why is J used in electric cables where Q is not? J used in electric cables where Q is not. That's J. Where is J? J. Okay, where Q is not. Okay, now this is very easy. J, let's write here. J has 3 delocalized electron. Delocalized electron. While Q has 2 delocalized electron. So J has more delocalized electron. So the more you have, the more electrons, the more delocalized it is, the higher the conductivity. So the higher electrical conductivity. It means that J conducts electricity faster because it has more delocalized electron. While Q has delocalized 2 delocalized electrons, the more delocalized it is, the higher the electrical conductivity. So J conducts more electricity than Q. Now P and J are termed as metalloids. What does the term metalloid represent? Okay, what does the term metalloids represent? They have both metallic and non-metallic properties. So that is called metalloids. You can't say it to be metal, and also you can say it to be non-metal. So non-metallic, metallic and non-metallic properties. How would you expect the reactivity of H and M to compare? H and M to compare with H. This is H and this is M. So which one conducts? Now for H, let's say H is 27, M is 287. The one which has fewer energy levels, it reacts easily. So its reactivity is higher. So H's reactivity is higher. To compare, H is more reactive than M. Okay, and why do we say that? Because reactivity increases. It reduces down the group. Down the group, reactivity reduces. Okay, because due to decrease. This is because due to the decrease of electronegativity down the group. So if you look at let's say fluorine is more electronegative, yani yakubali electrons more easily kwa vile ni due to decrease of electronegativity down the group. Okay, Now let's just say it, fluorine being 27, chlorine, sorry for that, fluorine being 27 and chlorine being 287, fluorine is more electronegative than chlorine. And the reason why it is more electronegative than chlorine is because fluorine is more is easily it gains electron easily because of the size. Ikiwa ni ndogo na ikiwa moja ni kubwa, ile ndogo ya gain rahisi kwa sababu the nucleus is very near to the incoming electron, while the one which is bigger, the nucleus much far to the incoming electron. So the one which is very near, it can gain electrons easily, and that is why it's said to be more electronegative. Okay, let's do this question. I'm really tired, but I just want to finish up this paper. It's a very lengthy video, and it's a very lengthy paper. 40 questions. Why? You use the scheme to answer the questions that follow. Solid N changes from yellow to white on standing. That is. So yamaanisha this is most probably zinc oxide, because zinc oxide is usually yellow when hot. Okay, yellow when it is hot, ikitulia huwa ni white when it's cold. Understanding yamaanisha hivyo. Okay, so it changes from yellow to white. Kuna lead oxide also. I think lead oxide is orange when hot, yellow when cold. Okay, but for now this is zinc oxide. So this solid N is basically zinc oxide. So you need to know by offhead. Okay, now zinc oxide, it can react with an acid, that is why it's a base, and it reacts with acids. So it reacts with sulfuric and it reacts with hydrochloric acid. So if it reacts with sulfuric acid, it normally gives you, because it's a base and an acid, it should give you a salt and water. So it gives you zinc sulfate plus water. If it reacts with hydrochloric as well, it's going to give you zinc chloride, which is obviously zinc chloride is is aqueous, which is a salt, plus water, which is liquid. And as always don't forget to write this states. Okay, but I didn't balance, but you should balance. So question B, write a balanced equation for the formation of Q. So just likewise, I've already written, but I didn't balance. So let's write it. Formation of Q, that is zinc oxide plus sulfuric acid. So zinc oxide plus sulfuric acid to give you zinc sulfate, okay, which is also aqueous, plus water, which is liquid state. Now let's balance. You have one zinc, we have one zinc, we have one sulfate, this is sulfate, we also have one sulfate, we have two hydrogens, and we have one oxygen. One oxygen is already balanced. You don't need to put any numbers behind any compound, so it's already balanced. Write the formula of the complex ion formed when sodium hydroxide is added to solution L in excess. Now, normally if you react zinc oxide with the sodium hydroxide, it's going to give you an insoluble solid of zinc hydroxide. Okay, but if you react in excess, it's going to give you a complex ion, because it's going to give you a complex ion, by the way, complex ion of tetra zinc hydroxide, something like that. But this is the complex ion, zinc this way, then 2 minus, it's called tetra zinc, no, it's called tetrahydroxo, because it's tetrahydroxo, it's called tetrahydroxo because of the hydroxonium ion, hydroxide ion, hydroxo, tetrahydroxo zincate. Okay, tetrazincate 2 plus. Okay, it's not hard. Now to our last question. Alhamdulillahi Rabbil Alameen. the last question of the day, question 40, using dots and crosses to represent electrons show bonding in H-2 and then S8, which is this one. Okay, now NH-2, so your nitrogen is 7, so it's going to be 2,5, and hydrogen is 1. So N H mbili. So N H mbili, let's write the 2 H's here. So N, so what it does, it basically this is the 2H. So what nitrogen does, itapeana moja, ita receive moja. Itapeana moja, ita receive moja. So it's going to be remaining, if you minus it by 2, should be remaining 3, but it's haito remain 3. So it's going to gain an electron from somewhere, okay, and that is hydrogen either or somewhere, but at the end of the day it's going to be written like this. So that is why imeandikwa minus hapa, so 1 electron is gained. Okay, I don't know where is it gained. I think this is something that you should know. So it's something like this, but I haven't seen such a question like this. Hey. Okay, and then we have the S8. The S8 itakuwa na 8 sulfur. Na hii itakuwa kubwa. So 1, 2, 3, 4, 5. This. That's how many? 1, 2, 3, 4, 5, 6, 7. Hata mwenyewe pia nakorogeka. Let me wrap it. This is 1, then 2, 3, 4, 5, 6, 7, and 8. Okay, that is enough. So basically what happens here is this way. It'll shade this and this. It's going to remain, no, sorry, because it's just sulfur, it should be excess. So sulfur. So if you donate EV, it's going to remain 2 here. Okay, this way it's going to remain 2 this way, because sulfur, remember, is 16. It's supposed to be 286. So nje kuna 6, and it needs 2 pairs. For each sulfur, it needs 2 pairs of electrons. That is why hii sulfur, let's say ya kwanza, this sulfur ya kwanza, it receives 2 pairs here. So 6 minus 2 is going to be remain with 4. So these are the 4. So the same thing with the other sulfur. So hii itachukua 2 pairs. So this is the first pair, second pair, and it's going to remain with 4 again. So this is the 4. So each sulfur will happen like that. So hapa itachukua 2 pairs, it's going to remain with 2 pairs, 2 that way, 2 pairs, and it's going to remain with 2. So though iko kubwa, it's something like this, 8 sulfur atoms. Now the last question, alhamdulillah, show bonding in carbon 2 oxide by use of this one or this one. So we'll take carbon 2 oxide is written like this, 1 carbon, 1 oxygen. So carbon and oxygen. Now what happens is carbon ni number 6, so it's going to be 2, 4. Oxygen ni number 8, so it's going to be 2, 6. So carbon needs 4 pairs and oxygen needs 2 pairs. Okay, so what happens is that carbon, the first pair watashare, so oxygen na carbon watatoa. The second pair watashare, oxygen na carbon watatoa. Okay, so it's going to be something like this, but the second pair is going to get it from oxygen, kwa sababu itakuwa ishatoa sasa 2, and therefore is going to get it from oxygen, kwa sababu oxygen iko na more electrons. So this is your bonding at the end of the day. So yeah, again, if you haven't subscribed, please subscribe to the channel. If you haven't understood, please tell me. I'll see if I'll upload videos, topical videos on chemistry. I've just started this one. I'm still continuing with the other one. So if you haven't subscribed, please subscribe to the channel. Tamam. Assalamu alaikum. I'm very tired. I don't know what to say. Assalamu alaikum wa rahmatullahi wa barakatuh.